All right, this is section 5.5, number 31, average distance on a parabola. What is the average distance between the parabola and the x-axis on the interval from 0 to 20? So let me draw what this might look like. I know it goes through 0 and 20. And it's a parabola, so it's going to look something like this, right? No, it's upside down. I'm sorry. I didn't see that. It's a minus x squared, so actually it's going to be flipped. Flip it. Flip it good. So it's going to go through the origin in 20. It's going to look like that, kind of, but prettier. So what is the average distance between the parabola and the x-axis? So the distance between the parabola and the x-axis from 0 to 20 are all these distances all the way across. So in other words, just another way of saying, what's the average value? What's the average value from 0 to 20? And there's no way we're going to add up all these y values. We're not going to add up all these y values and divide by the number of points. That's crazy. So we do the calculus way. So the average value, you integrate from 0 to 20, the function. I'm going to distribute this. So I'm going to get 600x minus 30x squared. And then I divide by the width, 20 minus a, 20 minus 0. So that is how you take the average value of any function, of anything, you integrate it and divide by the width. And as you saw from the video, hopefully that makes sense. This is like the volume of this whole region. And if you flatten it out and make it into a rectangle, that same area, that height would be the average value. So what does that have to do with anything? If you take the average value multiplied by the base, because that's the base, those two multiplied get the area of this gold rectangle. So that equals the area of the whole thing. So that's kind of what's going on. Hopefully it makes sense to you, not just memorized. All right, let's go. I'm trying to wake myself up. First, we find the antiderivative of that. So we add 1 to the exponent and divide by that, right? So we're going to get 600x squared over 2 minus, and then we add 1 to that exponent, so it's going to be a cubed over 3, 30x cubed over 3, 0 to 20, and then after all said and done, we divide by 20. Let's simplify. This will be 300, and this will be 10. So fundamental theorem. First, we plug in 20 here and here. That will get us 300 times 20 squared minus 10 times 20 cubed. And then I subtract, and I plug in 0 here and here. That's just going to give me 0. So I subtract 0. That's all over 20. All right, it's just algebra now. Technically, if this were an FRQ, that would be your answer. You'd be done. But that's 300 times 400 minus 10 times 8,000 over 20. And it's going to be 12 with 4 zeros minus 8 with 4 zeros, which is 4 with 4 zeros. One of the zeros cancel, and I get 2,000. And that's what the book said the answer was. So that makes me happy.